Okay, let's take a look at using multiplicative inverses to solve equations. We talked yesterday about reciprocals, and this is going to build right off of that. So lesson 5.6 and 5.7 go over two ways of solving equations. Different ways are desirable with different situations, but they both work to solve and get the answer in the end. So that's the good thing. Okay, so first of all, the multiplicative inverse property says the product of a number and its multiplicative inverse is 1. So for instance, if we have a number 3 over 4, its multiplicative inverse is 4 over 3, and when I multiply them, the product means to multiply, everything cancels, and my answer is 1. Is means equal. So it matches exactly. The product, multiply of a number is multiplicative inverse, inverse is equals 1, 1. So it tells us right here exactly what we're doing. If we also wanted to write it with in algebra using variables, you would say a over b times the inverse would be b over a is going to equal 1. Multiplicative inverse, there we have it, it equals 1. And the only requirement is we'd have to say a can't be 0 and b can't be 0 because we know that we can never have 0 in the denominator. So let's take a look at these equations. These two are one-step equations. We know going back to chapter 3 we have to get x by itself. We have this 4/7 we need to get rid of. So typically we would say, well, these are being multiplied, so we're going to do the inverse and divide by 4/7. Divide, divide. But then we start to get like big fractions over fractions, so that makes things a little too complicated. Instead, a better way of thinking of it is you have to multiply by the multiplicative inverse. What a fun word. So I'm going to multiply by 7 over 4, and what I do on one side I have to do on the other. We learned that before. We can put that negative 12 over 1. And now I see that 7's cancel, 4's cancel, and x comes down. And over here, we have like a miniature multiplication problem. I can cancel this 4. 4 goes into 4 once, and then 12 3 times. So I have negative 3 times 7 is negative 21, and the denominators were 1. So that's my answer. And just like before, you can always plug it back in for x, multiply this, and it should equal negative 12 so that you know that you got it right. It's a self-check. All right, letter B, same thing. We want to get k by itself. That's our goal. So whatever we're trying to get by itself, we take the multiplicative inverse of that fraction. So I'm going to multiply by negative 8 over 7 on both sides. Those all cancel. K comes down, and over here, negative 56 over 1, I'm going to see that the 7 and the 56, I get 8 times negative 8 is negative 64. And that's my answer. Let's try letter A, and then you try. I want to get m by itself, so I'm going to multiply both sides by the multiplicative inverse, which is 6 over 5, 6 over 5. Over here, everything cancels out. M comes down, and we're going to see again, nicely, we're going to have some things that are going to cross out. 5 goes into 5 once, into 24 times. 6 and 1, nothing cancels, but I can multiply 4 times 6 and get 24, and my denominators were 1, so my final answer is 24 over 1, or 24. Letter B. I'm going to multiply both sides by 9 over 2. These are going to all cancel. My x comes down, and that's my goal. And over here, 2 goes into 2 once, into 12 6 times. Denominators are 1, so that's gone. And 6 times 9 is 54. Letter C, I want to get x by itself again, so I multiply by 8 over 3, which is our multiplicative inverse. Everything cancels. X comes down, and I have a little bit of simplifying I can do. 5 times 8 is 40, and I'm done. Okay? Now we have two problems left. These are two-step equations. Go back to your rules of equations. You want to get n by itself. So the first thing we want to do is add 20 here. I'm going to add 20 to both sides. So my 20s go away, and on the right side I just have 3 over, not n. I'm going to add 20. Let's try that again. Add 20 to both sides. On the right side, my 20s go away. Negative 20 plus 20 is 0. And over here, I have 3 over 4n. And on the left side, negative 16 plus 20 is 4. So now I want to get n by itself. So I'm going to multiply by the multiplicative inverse, 4 over 3. 3's cancel, 4's cancel. And over here, I have 4 over 3 times 4 over 1. Nothing is going to cancel, so I just multiply straight across. 4 times 4 is 16. 3 times 1 is 3. So I get n is equal to 16 over 3, which as a mixed number would be 5 1/3. Okay? Now the very last one, we have a lot of fractions going on here, but all you have to think is we want to get p by itself. Now if the fractions are confusing you as to what you do first, you can almost kind of like put your hand over this denominator and say we have negative 2p plus 1 equals 5. What do I get rid of? 1, because I want to get that out of there first. And then go back, and that's going to highlight the fact that this 1/2 is what we're trying to clear out. So that might just simplify what you're looking at. Okay, so that being said, we want to get p by itself, so we get rid of this 1/2. I'm going to subtract 1/2 on both sides because it was a positive 1/2. Negative 2 over 3p comes down. These are gone. And on the right side, 5/6 minus 1/2, I can't do that. We know our rules of subtracting fractions say that we need common denominators. So my denominator is going to be 6. 2 times 3 is 6. Negative 1 times 3 is negative 3. So now I'm ready to subtract. 5 minus 3 is 2. So I find that my fraction is 2/6. So that's what I can put over there. And I can leave it here, or I can write it, move it closer to the problem. That doesn't look like a 6 though. So here, 2 over 6. If you wanted to simplify that to 1/3, you could, but we're also going to simplify at the end. So either way, you'll get the right answer. All right, now I want to get p by itself. So I'm going to multiply both sides by the multiplicative inverse, or the reciprocal, which is negative 3 over 2. Negative 3 over 2. Those cancel. That all cancels. Negative times negative is a positive, so p comes down. And over here I have 2 over 6 times negative 3 over 2. My 2's cancel. 3 goes into 3 once, into 6 twice. So I have negative 1 in the numerator over 2 times 1 in the denominator, which is 2. So my answer is p equals negative 1/2. And just like, again, with all of these equations, if you plug p back in, substitute it in, and see if it works, you're going to find out if you have the right answer or not, in which case we do. So we're good to go. All right, guys, nice job.